Well, welcome to the last event of the night for the Michigan State University Science Festival. I'm Roxanne Truen, and I'm pleased to be joined by Dr. Yang, who's going to talk to us tonight about how doctors see inside our bodies. So welcome, Dr. Yang, and thank you for being with us.
Yeah, thank you for the introduction. Okay, this is my presentation for this official event of the MSU Science Festival, and I'll talk a bit about medical imaging, and in particular, how we use science to solve problems in medical imaging, and that can help us in daily life. Okay. And so medical imaging refers to the techniques that are used to image the interior of the body. And this is typically different from the imaging sciences that we know. The usual imaging sciences are just to record what we can see. Okay? For example, if you take a photo of the scenery, you just take a snapshot of what you can see from your eyes. Okay? But for medical imaging, what you want to see is something that is underneath the skin or the bones. And so we need to find a way to probe the interior of the body without breaking into it. So this is why medical imaging is much more challenging than just ordinary imaging. And today I'll use the X-ray CT as an example to introduce the principles of medical imaging. And because this is a method that's probably the most popular one. Okay. So as we have explained, medical imaging are the techniques that a doctor use to see inside our body for diagnosis, for clinical analysis, and for medical intervention. And there have been a lot of different techniques in medical imaging. We have mentioned CT. This is an example we are going to talk about in detail today. And we actually have a lot of other techniques, and I'll leave you a few seconds to think about this. What kind of medical imaging methods you have heard of? Okay, you probably have come up with a few names in your mind. And some of the most commonly used medical imaging techniques are radiography, which is based on X-ray, and magnetic resonance imaging, which is abbreviated as MRI, and ultrasound. This is a special kind of wave that some mammals like bats use to detect objects. And there are much more than the list I gave here. For example, we can use visible lights for imaging. And this is probably pretty surprising that there are also techniques that you can use the lights on your cell phone for imaging nowadays. But among all these techniques, X-ray is the one that is most useful. So today we'll take X-ray as an example to introduce how medical imaging works. Okay, a brief history about X-ray. This X-ray was discovered by the German physicist Wilhelm Röntgen in 19th century. And Röntgen discovered this kind of ray when he was performing experiments in his lab. He observed a kind of ray that is invisible, but is able to leave traces on his photographic plates. So he realized that this is something new, and he wrote a report to let the scientific community know about this. But at that time, he did not know what this ray really is, so he named it as X-ray. And the letter X means unknown or mysterious. But nowadays, we have known very well about this X-ray. We are able to measure the frequency, we are able to measure the wavelength, but still we follow the convention to name it just as X-ray. Now, Röntgen discovered this X-ray, and someday he showed this to his wife. So he placed his wife's hand below the X-ray source. And then on the other side of the X-ray, they see an image like this. And on this image, we can see clearly that the bones, even the joints. And when his wife saw this, she was completely shocked. And she said, I have seen my death. But now we know this has nothing to do with death. This is just a special property of the X-ray that makes it very useful. But this simple experiment marked a historic date, which is December 22nd, 1895. And this date now becomes the first day that human beings use medical X-ray. Okay, now it is very simple to make a shadow with X-ray. Now the way to do this is if you have an X-ray source, and this X-ray source can emit X-rays. So these X-rays go to different directions. And if we put your hand here, these X-rays leave a shadow on the photographic plates. Okay. But what makes X-ray useful is that it has the ability to penetrate objects. And its ability of penetration is related to the density of the object. For example, here, for the soft tissue and skins, the X-ray can easily penetrate them because they are less dense. But for those dense parts like the bones, it is much harder for the X-ray to get through. And therefore, if you look at the image of this X-ray, there are light parts which indicate the soft tissue. It has a large accumulation of X-rays. And there is also the dark part, which corresponds to the bones, because there is less X-ray that goes through from the bones. All right, so this is the basic 2D X-ray radiography, which is just like you project the shadow of the hand with the ability of penetration. But the problem with the 2D radiography is that it just gives us the width and height of the object. We have no information about the depth. And so there are very smart scientists which discover ways that can compensate the loss of depth in using X-ray. And here is an illustration of the 2D X-ray. As we have seen before, we have an X-ray source on the top, and now here is the human body that we would like to image. And on the other side, we have a photographic plate, which can collect the X-ray. Now, at the bottom of this image, of this illustration, this curve shows the accumulation of X-rays. So when you have more X-rays that pass through, you have a higher accumulation. And when you have less X-rays that pass through, you have a lower accumulation. Now, the smart idea of the scientists is, well, we can, instead of using just one projection from this angle, we can use multiple projections. For example, we can rotate the source and the plates to get these images or the shadows from different angles. Okay, in this way, we get images, a lot of images, and we stack them at the bottom. So let's watch this video again. It gives a very clear illustration of how it works. Now we see that every time we get a shadow, we place the shadow as a slice. We place the shadow as a slice here, and then we stack all these slices, and we get an image like this. Okay, of course, this is not the image of the body itself, right? But there is some information about the body inside this image. And this technique is known as X-ray computed tomography. So computed means we need to use computer to aid the computation of the image. Tomography means imaging by slice. And these words are often abbreviated as CT. So this is what we call X-ray CT. It's a 3D medical imaging technique. Okay, and now this X-ray CT has found wide application in our daily lives. For example, if you visit a dental clinic, you must have seen this before. This is a 3D dental cone beam CT machine. And the way to collect the data is, we see that there are two handles on the two sides. And now you start rotate these two handles. And when the rotation finishes, you collect all the data that you need. Okay, and now based on the last slide you have seen, we know that this rotation actually gives us the images or the projections, the shadows from different angles. So what is really going on here is in one of the handles, there's the X-ray source. In the other handle, there's a photographic plate. Now this source projects the human body from different angles, and the plate collects the X-ray data. Okay, now upon completion of the collection of data, we are now in the position that now we have this kind of strange data. And what we really need in X-ray is to view the interior of the human body. And so there's a question of how to go from data, this strange pattern of data, to the image that we want. Okay. And this is what we need, where the science comes into play. And for this purpose, for the reconstruction of this image, we need to study the mathematical models of the X-ray imaging process. We need to build up the mathematical models between the X-ray data, which is the data we collected here, and the patient, the structure of the patient, which is what we hope to image. And for this, we need the help of calculus, algebra, and geometry. And after we have discovered the relation between these images, we need to design algorithms and implement algorithms to compute the image based on the data. And now there are many different algorithms for the computation. And we have the conventional model-based algorithms, and nowadays there is a lot of algorithms that use advanced data science tools and machine learning. And this is what we do in my department, which is the Department of Computational Math, Science, and Engineering. So we use advanced tools from mathematics combined with programming to solve real-world problems. Okay, now let's look at the CT image formation process. Now we have seen that from one angle of projection, all that we have is this density of X-rays on the photographic plates. But now we want to use algorithms to recover the patient body. And the idea to do this is we use the data slice by slice to reconstruct the information and then put them together. So on the left-hand side, this is the reconstructed image using our algorithm. On the right-hand side, this is the original image. Now the way to reconstruct the image is we use the data from different angles. Okay, now we see those. Okay. Oops. Let me stop at somewhere in the middle. Okay, now the idea is we take the data slice by slice, and you see that this horizontal line indicates we are using the data from this slice. And we apply the algorithm to get some information about the image. And we add that information to the reconstructed image here. And by doing this slice by slice, we get more and more details about the original image until after we run out of all the data, we have successfully reconstructed the image. Okay, so we have seen that now using 2D images from different angles, we can actually build a 3D model This is the 3D computed tomography. And so you may wonder why we want to bother to construct a 3D object from a 2D. And so here we can see the difference. Now for a 2D image, as we have seen that all the information we have is width and height. We lose the information of depth. So for a doctor, if a doctor discovers something unusual, all that the doctor can see is the size of that object. But the doctor does not really know how large that object can be. But if we collect the information, we collect the 2D images from different angles and assemble a 3D image, there's much more that we can do. For example, we can build a 3D model. This is a 3D model of the teeth. And we can look at the front of the teeth, and we can even rotate it to look at the back of the teeth. And we can use this technique to locate the unusual object and even to guide the surgery. So that when a doctor performs a surgery, the doctor does not have to look at the patient, but all that the doctor needs is a computer. And by looking at the computer, you know where your hand is, you know where the tool is, you know where the teeth is, and you have quantitative information about everything that can guide you to complete the surgery. Okay, so this is why the 3D reconstruction or the 3D CT is much more useful than just a 2D radiography. Okay, and this illustration shows the part of the research in my group. And the process of going from data to the image is called inverse problems. So the research in my group is about inverse problems and its application in medical imaging. And using advanced tools from mathematics and algorithms, we can solve some real-world problems that can have real impact to the daily lives. And this is what I want to talk about. Thank you very much for your attention.
Thank you, Dr. Yang. That was really interesting. And I've never seen the three-dimensional teeth before, so that was really interesting. I would imagine, like, if you need braces or jaw reconstruction, it would really help the dentist to see a three-dimensional model for your jaw.
Yes, you can see the model from different angles. You can drag it, you can rotate it, and you can look at every detail of that. Compared to in the 2D, everything is stacked over, and you just see one image.
And for those of you listening on the Zoom webinar, if you have a question for Dr. Yang, you can type it into the Q&A. And if you're listening on Facebook, you can ask your question in the comment section. So I'll give you a few minutes for that. So you've shown us some of the dental stuff. Are you working on any other areas of the body as far as your inverse problems and imaging group?
Our techniques can be applied to a lot of different imaging sciences. Like you can image the brain. You can image, for example, the lung to locate a tumor for lung cancer. And you can image different, you can also have vascular imaging as well. So this imaging of teeth is just one example of what we can, where we can apply these imaging tools to help us.
And are these available to dentists now, or is that something coming in the future that you hope to see?
So some of them, the imaging methods have been well used, like for example, the ones I listed, like computed tomography, magnetic resonance imaging, ultrasound. These have been in daily use. And there are also other emerging techniques. For example, there are techniques that combine these standalone methods. For example, you may combine X-ray CT with ultrasound. And the advantage of the combination is that some techniques have better resolution, some others have better contrast. And by putting them together, you will be able to have an image of both high resolution and high contrast.
I would think it'd be really important on like spinal columns, seeing where all the vertebra and the discs and the spinal cord and all live, maybe combining that in some way. That would be a help for spinal surgeons, for neurosurgeons.
Right. So once we can improve the quality of the images, we can more precisely locate for example, the disease, and we can better guide the doctors during their surgery. So there's a lot of advantages if you can have an improved quality, if you can have an image with improved quality.
Yeah, awesome. Well, we don't seem to have any questions, so I guess we will sign off for the night. We have one more night to go for the MSU Science Festival. Tomorrow night, we're going to learn about what plants to plant in your yard to attract songbirds. And thank you again, Dr. Yang, for joining the festival this year. We really appreciate it.
Thank you very much.
Good night.
Good night.